Okay, so this evening's session we're looking at the Paper 1 GCSE Intermediate Maths from November 2018. We've already filled in our expected boundaries, so if we get everything right up to and beyond, up to and including question 9, it takes us beyond that C threshold, and every mark we pick up beyond that is pushing us towards a B, or is absolutely consolidating what we've got in the first half of the paper. We've already come into the exam, we've already filled in and written down all the other important formulae that we may need to use. So, question 1. Do you want me to zoom in a bit? So consider the following list of numbers. Using only the numbers in the list above, write down the 3 cube numbers. Now, cube number, most people know what a square number is. It's what you get when you multiply a number by itself. A cube number is what you get when you multiply by itself 3 times. Now, they're not going to be expecting you to know loads of these, but they would be expecting you to be able to figure out 1 cubed. 1 times 1 times 1 is 1. 2 cubed. So 2 times 2 is 4. 4 times 2 is 8. 3 cubed. 3 threes are 9, 9 threes are 27. That's on our list. So that's 1. 4 cubed. 4 fours are 16. 16 times 4. If you double it, you get 32. Double that, you get 64. 64 is on the list. And 5 cubed is another one that they could expect you to use. To know, 5 fives are 25 times 5 is 125. So those are the 3 cube numbers. A number that is both a square number and a multiple of 9. So your square numbers, 1 times 1 is 1, 2 twos are 4, 3 threes are 9, 16, 5 fives are 25, 6 sixes are 36. So I've got 2 square numbers in my list. 7 sevens are 49. 64 is also there. So those are square numbers, that one, and that one. But it's also a multiple of 9. So it also lives in the 9 times table. So that one doesn't. That one does. 4 nines are 36. So the one that satisfies both of those is 36. A number that is a factor of 81 means it's a number that divides exactly into 81. Okay? Now, one quick way of doing this is using the check to see if something divides by 3. Okay? For something to divide by 3, when you add the digits together, if it gives you a number that is in the 3 times table, it divides by 3. So 8 and 1 is 9, so that divides by 3. Add those together, you get 7, so that doesn't divide by 3. Add those together, you get 9, so that divides by 3. So there's a chance that 27 goes into 81 because they've both got 3 as a factor. So I know double it is 54. What would 3 times 27 be? Let's have a look. 3 sevens are 21. 6 and 2, 81. So it is 27. Okay, so that little divisibility check for 3 is a nice little trick to remember. Using only 2 numbers from the list, fill in the spaces in the following statement. Dividing blank by blank, and then rounding the answer to the nearest 10 gives an answer of 30. So the bigger number is going to be going there. When I divide it by a smaller number and round it to the nearest 10, it comes to about 30, or it comes to 30. So I'm looking there, and I'm seeing that 4 times 30 is 120. Yeah, 4 times 30 is 120. So the one there closest to me getting that would be 125 divided by 4. And that would round to give an answer of 30. Okay, so you're just trying to play around with that. They're really irritating questions because they eat up your time. So the marks for that, just pretty straightforward. There's the mark scheme. Oh, I haven't brought the mark scheme down. Sure I did. Okay, I'll have to make it up to that. So you get 1 mark for 2 of those right, 3 marks for all of them right. 1 mark for that, 1 mark for that, and 1 mark for that. So there's no method there, you're either getting those right or wrong. Question 2. Draw an accurate scale drawing of the triangle shown above. Use the scale 1 centimetre represents 3 metres. So there's 2 things they're testing here. One, your ability to work with a scale, and the other, to then actually measure accurately. So every 3 metres you've got on the page is going to represent 1 centimetre on the diagram we're going to draw. So 18 metres will become 6 centimetres, and 24 metres will become 8 centimetres. Now 55 degrees isn't something you can construct. They're not asking you to construct, they're asking you to draw. So that means you can use these things. So if we start off with AB and measure AB as 6 centimetres, we then need to measure a 55-degree angle from A. So we need to put the centre of the measurer on A, and we need to line the 0 up along the line that we're measuring the angle from. So we're turning from this line, so we're going up in that direction. And in that direction, the counting scale goes up 10, 20, 30, so it's the inside scale we need to go. And we need to go up to 55 degrees. Which is there. So 55 degrees takes me up to there. And then I need to measure along here 8 centimetres. So I haven't drawn my line far enough. So 8 centimetres will be to there. And then you would measure, you would draw your line through like that. And where the 2 lines cross is where C is. So that's 8 centimetres. That's 6 centimetres. And that angle is 55 degrees. So the mark scheme for that, there'll be 1 mark for correctly drawing or correctly working out the scales. So there'll be 1 mark for reducing it to 6 and 8 centimetres. Then there'll be 1 mark for drawing the 55 degrees. And the last mark for completing the triangle. So those will be all B marks. Okay, so you have to be careful. Sometimes they'll ask you to construct where you have to use a compass. Okay, if it says construct, you can't use one of these. If it says draw, then you can. Use your scale drawing to calculate the actual length of the side BC. So now we've got to do the opposite. We've got to measure BC in centimetres. And I get that to be 7 centimetres. So if it's 7 centimetres on the page, using this scale, it's going to be 3 times as big in metres. So that will be 3 times 7 is 21 metres. And if you do something wrong here, so you've got a different measurement there, so long as you've correctly multiplied your measurement by 3, you'll get those marks.
Well, from what I've measured here, from this pig as well, 8 centimetres.
Right, I'll have a look at it when I stop halfway. I'll take a look, all right? So for that one, you've got a method for multiplying by 3 and an answer. So then we come to some algebra. Simplify the expression 15x minus 2y minus 7x minus 4y. So remember, each term in that expression has got 3 parts. The sign tells you whether it's positive or negative. The number tells you its magnitude, how big it is, and the letter tells you what variable you're linking it to. So I got a 15x take 7x. That one hasn't got the magnitude because we don't bother writing the plus in. So that means on a number line, you're at 15 and you're going down 7 places. So you're doing 15 take away 7 leaves you at 8x. Then we consider the y. So I got a minus 2y there and a minus 4y there. So on my number line, I'm at minus 2 and then I'm taking off another 4. So I'm moving down the number line and I end up at negative 6y. The most common mistake or confusion there is when you get confused with, well, that's a minus and that's a minus, which makes a plus. That's only when you're multiplying. We're not doing any multiplying there. We're just moving up and down a number line. So there'd be 1 mark there for the 8x and 1 mark there for the minus 6y. Then we've got a straightforward equation. So you remember, when you're trying to solve an equation, you want to get the m on its own. But the first thing to deal with there is the negative 7. You do the opposite of take 7, which is add 7. And if you do that to that side, you have to do it to the other side as well. So the left-hand side then just leaves 2m on it, because those cancel each other out. And on the right-hand side, I got 12 add 7, which is 19. The 2 and the m are joined by a times. So then I've got to do the opposite of timesing by 2, which is dividing by 2. And I have to do that to both sides. And you can leave it like that. 19 over 2 is fine. If you want to cancel it down or divide it to get 9.5, that's fine, or 9.5. So the method mark for that, there'll be 1 mark for getting it down to 2m equals 19, and 1 mark for your final 19 over 2. Part C, calculate the value of 5f plus 3g when f is negative 4 and g is 7. So whenever you replace a letter with a number, put it into brackets. So the f becomes bracket negative 4 and the g becomes bracket 7. Then all you need to remember is when you're clearing out brackets, you multiply. So I have 5 times 4 is 20. That's positive, that's negative. So now we're multiplying. Those laws of negative numbers come into play. So 2 signs are different. The answer is negative. 7 3s are 21. That's positive, that's positive. Signs are the same. The answer is positive. Then it becomes a moving up and down the number line. So you're at negative 20, you're going up 21 places, you end up at 1. So the marks for that, there'll be 1 mark for a correct substitution and evaluating, and 1 mark for the final answer. Question 4. So a regular form of question on these papers is where they give you something geometric and get you to form an equation out of it. Sometimes it's to do with the values of the angles, which we've seen on some papers. On this, it's to do with the lengths on the sides. So the perimeter of the triangle is 18 centimeters. So perimeter is how far you travel to go from there right the way along the outside of the shape and back to the start. So from that I know that x plus 8 plus 7 equals 18. So x, 8 and 7 is 15, equals 18. Take 15 off both sides, x equals 3. So now that I know x equals 3 from the information they gave me on the triangle, when I look at the rectangle, rather than thinking that as being x plus 2 now, I know x is 3. So that's in effect 3 plus 2, which is 5. So to calculate the area of the rectangle, I need to know area of a rectangle is length times width. So the area will be 6 times 5, which is 30. And the units, it's not asking you for units, so you wouldn't get penalized by leaving them out, but it's a good habit to get into. So the area is 30 centimeters squared. So the marks for that, you get 1 mark for forming the equation that enables you to get a value of x of 3, and then 1 for finding out the sides in the rectangle, and 1 for the correct area. So that's question 4. Question 5, the trigger word here is estimate, which means they don't want you to do pages of stupid calculations. They want you to round those to one significant figure. So 59, they're going to want you to round to 60, 301 to 300, and 1,997 to 2,000. 6 times 3 is 18, followed by 1, 2, 3 zeros, divided by 2,000. Now you can divide repeatedly by 10 for every corresponding naught you have on the top and on the bottom. So I can divide by 10, takes those off, by 10, takes those off, by 10, takes those off, leaving me 18 divided by 2, which is 9. So the only time you wouldn't round to one significant figure is if it had a square root in it. So if you had something like the square root of 100 and, oh, bad choice. Let's say you had the square root of 93. Okay, you'd round that to 100. Round it to one significant figure, you'd have the square root of 90, which you can't do without a calculator. So by rounding it to 100, it means you've got a square number under there, so it becomes 10. Okay, so if they give you a square root, you round to the nearest square number. That comes up occasionally. Okay, they like this sort of question as well, where they give you not only a calculation, but the corresponding answer. So given 341 times 57 is 19,437, write down the answer to each of the following. So what you do is match the digits first of all. So with this one, I've got 3.41 times 5.7. It's got that digit and that digit, which means the answer is going to contain those digits. Has to. The only difference is where the decimal point goes. To decide where it goes, the easiest thing to do is just to round those off. So that's roughly 3, that's roughly 6. So estimating the answer to that is 18. For that to be anywhere near 18, the decimal point has to go there. With this pair of numbers, the missing part of that sum is the 341. So what I'm going to do here now is estimate that as 20,000 divided by 600, I can knock off 2 sets of 0, so that's roughly 200 divided by 6. Well, it's not going to go 3 times, it's not going to be 341, it's going to be 34.1. So just by selecting the right digits and then estimating to find out where to put your decimal point. So for that one, there's 1 mark there for correctly rounding to significant figures, 1 mark for your answer, and 1 mark for each of those. Question 6. So this is the OCW question, which means how we lay it out earns us an additional 2 marks. So let's read what we've got. A box contains 5 identical balls numbered 1 to 5 respectively. 1 ball is chosen at random from the box. Its number is recorded and the ball is replaced in the box. The process was carried out 75 times in total. How many times would you expect an even numbered ball to have been chosen? Okay, well, let's figure out with the balls first of all. So I got 1, 2, 3, 4, 5. 5 balls. I'm interested in even. There are 2 of them which are even. So the probability will be, so the probability of drawing an even number will be 2 out of 5. The process was carried out 75 times. So to find out how many times you would expect out of 75, you would be doing 2 out of 5 times the number of times it's repeated. So I've written, so if process repeated 75 times, your words, doesn't matter what you do, so long as you're demonstrating, you know that you're going to work that out. So you have to do 2 lots of 75 is 150 over 5. 5 into 15 goes 3. So you would expect it to, an even numbered ball, to come up 30 times. Yeah, 2 lots of 75. Doesn't matter, you could have done it. How many times does 75 go into 5? Yeah. So work out 1/5 first of all. 5 was into 7 once, remainder 2. 5 was into 25 5 times. So 1/5 is 15. So 2/5 is 30. Doesn't matter, when you're multiplying fractions, it doesn't matter the order you do it, only when you're adding or subtracting. A really common mistake people make is they would then write this as 30 out of 75. Okay? That's wrong, and they'll penalize you for it, because that's a fraction which is smaller than 1. So don't write that. How many times? 30 times. So for that, there will be 1 mark for the 2/5, 1 mark for the method of writing down 2/5 times 75, and 1 mark for getting 30. Then your OCW is just for showing how you get the 2/5, so draw a little picture, nice and easy. Then writing down probability of even, doesn't have to be a full sentence. Repeated 75 times and times at the end. So it's just for showing how organized you were. 2 marks for that OCW. Question 7. So we're talking bearings. With bearings, you have to remember, for your learning part, is that you measure clockwise the angle turn from north in that direction. So north is where you line your 0 up. This is saying it's not drawn to scale, so you can't measure it. Even though it looks like it's something you can measure, it's not going to help you. What is the bearing of x from point P? So if we're standing at P and we're turning through that angle until our line of sight is pointing to x, we've gone from north to south, which is 180, plus another 34 degrees. 8, 11, so we've gone 214 degrees. Part B. The diagram below shows 6 points on the map. The diagram is drawn to scale. All of a sudden, we can play with this. Because it's drawn to scale, it means we can use our angle measurer. A ship sails from point P on a bearing of 107 degrees. It sails towards one of the 5 points A, B, C, D, or E. Which of the 5 points is the ship sailing towards? So, from P, we put the center of the measurer on P, and we line up the 0 with north. So there's my 0. Lined up with north, and I'm turning through 107 degrees, and you have to go in the clockwise direction, so it's the outside scale to 107. There's 100, there's 110, there's 107. So I can see it's going through A. A second ship sails from point P for a number of miles on a bearing of 70 degrees. Okay, so 70 degrees is there. So he's traveling along that path. Okay, so it's chugging up there, the ship. It then changes direction and sails on a bearing of 270 degrees. Now 270 degrees, if you have a look at your measurer, if north is right the way up, 270 is east. So he's chugging up there, and then all of a sudden he goes like that at some point. It is possible for the ship to reach only one of the 5 points. Which point can the ship reach? Well, if he's going in that direction and then suddenly heads east, the only one of those he's going to get near is E, because all the others are below that east-west line. So marks for that on bearings: 1, 2, 3. So all you need to be aware with bearings is when you can or cannot use that. If something is drawn to scale, or they ask you to draw it to scale, you can measure it. If they don't, then you're basically using angle properties of straight lines, 180 degrees, and parallel lines sometimes with north-south. Question 8, parallel lines. Line AB is parallel to the line PQ. And we can see they've got little arrows on there to trigger that. Find the size of each of the angles A, B, and C. So we've got A, B, C. As soon as you look at parallel lines, start looking for Z's. Okay, so I can see there that I've got this line that's cutting the 2 parallel lines, creating this angle and that angle within that Z shape. So those are the same. So A is 52. Usually, the order that they letter the angles they're trying to find is the easiest way to figure them out. So A is probably the easiest one to figure out before you start. Then we come to B. Well, B is directly opposite A, so those are the same. So if that's 52, that's 52. So I now know that A is 52 and I know that B is 52. Now to get to C, well, there's different ways of going about this, depending on which angle property of parallel lines you want to use. I can see that I've got another Z here. So Z, C and X are going to be the same size because they're within that Z. I don't know what X is, but I do know it's on a straight line there. So if I take that away from 180, it gives me X. And if I know X, I know C because of that Z. But another angle property that of parallel lines that you might know is that those two angles there add up to 180. So if you've got that inside, sometimes math teachers call it a C angle, because you've got that letter C, those two add up to 180. So whichever way you go about doing it, you've got to do 180 take away 116. Can't take 6 from 0, so you have to borrow from the next one. So it's 6 from 10, which is 4, and 1 from 7, which is 6. So C is 64 and X is 64. So they haven't asked us to work out yet, but it's coming. So A is 52, B is 52, C is 64. 1 mark for each of those. Then it says, find the size of each of the angles X and Y. Well, I've just worked out X, it's 64. Hence, give the special name for triangle LMN. So LMN is this triangle. I know those two angles. So if I add those up and take it away from 180, it'll give me the missing angle inside my triangle. So if I do 64 plus 52, I get 116. And if I take that away from 180, I've already worked out that that is 64. So Y is 64. Now, how does that make this triangle special? Well, 2 of the angles are equal, which means it's an isosceles. So the special name is an isosceles triangle. So there's 1 mark for each of the angles and 1 mark for naming your shape, naming the triangle. So long as it's clear that you were trying to say isosceles, they wouldn't penalise you. All right? The only one you penalise for spelling is the OCW question. Okay, so the last of the overlap with foundation tier is a transformations question. So reflect the triangle in the x-axis, then translate the reflected triangle 5 squares left and 2 squares up. So there's 2 things you've got to do here. When I did this, first time I videoed it, I missed this. I didn't read the second part. So first of all, it's a reflection in the x-axis. This is my x-axis. So it's saying that your mirror is going to be placed along that line. And the reflection is exactly the same number of squares beyond the mirror as it is to the mirror. So that corner there is 3 squares above the mirror. So it's going to end up 3 squares below, then there, and then there. So that is following the reflection. And then it says, we will now want you to translate it. When you translate, you move, but you don't change its orientation. So it's just being moved. It'll stay in the same position as far as turn is concerned. So 5 squares left. So this top corner here is going to move 1, 2, 3, 4, 5. And then 4 up. 1, 2, 3, 4. This corner, 1, 2, 3, 4, 5. 1, 2, 3, 4 to there. and then you can just complete from there. So this one, 1, 2, 3, 4, 5, 1, 2, 3, 4. So the final resting place of my triangle is going to be there. So there's 2 marks for the original reflection, and then 1 mark for the translation after it. Now, with the translation, depending where this question comes up on the paper, if it's on the overlap with the foundation tier, they're going to ask you to translate like that, 5 squares left, 4 squares up. If it's on the overlap with higher tier, so if it's a couple of questions further in, they could give you that as a vector which would look like this. 5 squares left would be -5, and 4 up would be written underneath it like that. Okay? So with the translation, be aware that they could either ask you to write it like that, or they'll give it you like that if it's further on in the paper. Part B. The circle below is rotated 90 degrees anti-clockwise about the origin. So with a rotation, they have to give you a turn, they have to give you a direction of turn, and they have to tell you where to pin your tracing paper. So what we're going to do is, there's the origin, 90 degrees anti-clockwise, is in this direction, opposite to the way the hands on the clock travel, and 90 degrees means that that arrow is going to be pointing in that direction. So you pin your tracing paper where it's telling you the center of rotation is going to be, and you turn it until the arrow is pointing in the direction you're expecting it, and the center is going to end up there, which is at -3, 5. Remember, with a coordinate, the x coordinate is always first, so the horizontal -3 and then up 5. So 1 mark for that. Okay, and we'll stop there.